Now I will talk about the question generation part of our project. This is our entire workflow and the libraries used. For question generation, we first pre-process the document to extract sentences that can be turned into questions. We use spaces to perform sentence segmentation on the document. To avoid asking insignificant questions, we also filtered out sentences that are too short. The required length is determined empirically. Then, using spaces dependency parser, we extract sentences that have a subject and at least one direct or indirect object. For sentences with more complicated structure, we will only extract the main clause using the previous criteria and ignore the part after the conjunction. For each question, we can generate three types of questions: binary questions, what and who questions using direct objects, and when and where questions using indirect objects. For binary questions, we use spaces part of speech tagger to get the tense of the root verb. We then conjugate the verb do using the same tense as before. Then we add the base form of the verb to generate the question. When the root verb has an auxiliary, we swap the auxiliary verb and the subject. We also use the NeuroCoref module to resolve any pronoun issues. So far, all questions generated this way are answered yes unless there's a negation in the original sentence. But we actually omit the negation from the sentence because it is redundant. The negation doesn't really change the question as shown here. Since most sentences don't have negation, to generate binary questions for which the answer is not always yes, we replace a named entity in the question. With 0.5 probability, we will use spaces named entity tagger to find a non-subject named entity, which we replace with a sister term found using WordNet. This allows us to generate more meaningful binary questions. And when outputting the questions, we prioritize these questions over the other binary questions. More on that later. For what and who questions, we replace the direct object with this appropriate WH word, and then generate the rest of the questions the same way as before, this time keeping negations intact. When the name entity type of the object is person, we replace with who, otherwise we replace with what. Similarly, for indirect objects, we replace them with when and where, when it is appropriate to do so. So specifically, when the name entity type is a date, we replace with when, and when it's a location or geopolitical entity, we replace with where. If the preposition for this object is to or from, we keep it to preserve grammatical structure. And finally, for the output system, we use a priority system. We first output the binary WH questions, and then we output the good binary questions with name entities possibly replaced. And then we use bad binary questions with predictable answers. And finally, if we are still not reaching the target, we will pad with the last question.
Moving on to the question answering part. The entire workflow has 4 steps, but we'll go into details one by one. For step 1, we process question file and wiki file by doing code reference and removing invalid text, similar to what we did in question generation part. At step 2, we'll identify the question type and change it to predicate form. We first identify the question type by examining the first word in the question, then we use Stanford parser to generate a parse tree and analyze its structure to get the predicate form. The methods will be introduced on the next slide. Lastly, we use pattern.en to change the verb to its correct form. Here are the rules we use to change each type of questions to predicate form by analyzing the tree structures. For a quick example, if the input sentence is what did John eat last night, we start by identifying that this question is a what question. Then we get the structure of the question and change it to predicate form. Finally, we use pattern.en to change did eat to eat. In step 3, we find the best matching sentence which has the highest cosine similarity score. In step 4, we create different methods to answer each type of questions. To identify different question types, we use the tags mentioned earlier. For each target sentence, we use spaCy NER label to create dictionaries, and go to target dictionary to find the final answer. For instance, if question tag is who, we will go to the person dictionary to find the answer. As for binary questions, we see if the important words in the question are also in the target sentence, or if their morphemes are the same as the morphemes of words in the sentence. We also look for synonyms and antonyms for verbs, adjectives, and adverbs. To see if there's negation in the target sentence, we count negations before the root verb. If the root verb is an auxiliary verb, we look at the word after it. To answer why questions, we look for these 4 keywords in the target sentence. We return the part of sentence after word since, because, and due to, but return the part before the word so. To answer when, where, and who questions, we try to separate the target sentence into clauses using Stanford parser tree, and then go through the clauses until we find a word with its desired NER tag corresponding to the question type. Here's one brief example of our question answering flow. First, we change the question to predicate form and identify its question type. Then we find the target sentence with the highest similarity score and transform it into a new list with all the clauses. Then we sort the clauses by their similarity to the question and loop the sorted list until we find a matching answer, which in this case is New York City because it has a location tag. And that ends our report video. Thanks for watching.